Another example of being able to solve a second order differential with by using the method of undetermined coefficients. We have this 4y double prime minus 4y prime minus 3y equals cosine of 2x. So the first thing we need to do is we need to find the complementary solution. So yc, and that's just going to be found when we factor and put together first of all the auxiliary equation. So that's going to be 4m squared minus 4m minus 3 equals 0. And we're going to factor that. When we factor it, we're going to factor it into 2m and 2m minus 3 plus 1. And that should give us our two solutions that are necessary to be able to solve the complementary solution. So we're going to get that m1 is going to be minus 1/2, m2 is going to be positive 3/2. All right, so that means we have a case 1, and our yc is going to be equal to this c1e to the minus 1/2 x plus c sub 2e to the 3/2 x. So that's the easy part. The more difficult part is when we try to get the particular solution. And this one's a little bit sneaky because an initial guess that we might have for this would be a cos of 2x, which is a good guess, but unfortunately it's not complete. And the reason it's not complete is because we know that there are some derivatives of the function sine 2x that will result in at least a partial sum of cos 2x. So in addition to a cos 2x, we also need b sine 2x. All right, so we have to be careful with that, and that's true every time we have a sine or a cos as our as the right-hand side of our function for these non-homogeneous types of differentials. Now, what you'll notice is that we need a first and a second derivative, so we're going to get y prime of p. We have a chain rule, so it's going to be negative 2a sine 2x plus 2b cos 2x. And then finally, y double prime of p is going to be equal to another chain rule. So we're going to have negative 4a cos 2x minus 4b sine 2x. And now what we're going to have to do is we're going to have to substitute everything back in to this. Okay, so now remember the original differential was 4y double prime minus 4y prime minus 3y is equal to cos 2x. And so we're just going to substitute all of the above. We might be able to combine some like terms. All right, so we're going to get 4 times the second derivative. So that's going to be minus 4a cos 2x minus 4b sine 2x. And then we're going to have another minus 4. And that's going to be times this first derivative. And our first derivative is negative 2a sine 2x plus 2b cos 2x. And then finally we just have minus 3 times the original guess, which was our a cos 2x plus b sine 2x. And remember, all that's equal to cos 2x. So here's where we hope that there can be some like terms to combine. All right. And for the terms to be like, remember, we have to have both the variable, the undetermined coefficient, so in other words, the a has to be like, as well as the trig function. So we're looking for an a cos 2x. And the good news is that we have negative 16 of these a cos 2x's, and we have negative 3 a cos 2x's. So when we combine those, we get a little bit more simple, and we're going to get negative 19a cos 2x, so that's good. And we also have the same thing going on with these b's. So we have negative 4b sine 2x and negative 3b sine 2x. So remember, that's negative 16 right here from the 4 times the 4, and then negative 3. So it's another negative 19. That's b sine 2x. So that takes care of those two combined, takes care of those two, and then unfortunately we still have these unlike terms. They're just like unlike anything else, so we're just going to add those in. We're going to distribute, and we're going to end up with 8a sine 2x and minus 8b cos 2x. And again, that's all equal to cosine of 2x. Now we have to try to create our system. And the system's actually going to be pretty easy because anything with a cosine is going to be equal to the cosine. Anything that's equal to sine is going to be equal to a 0 in this case. All right. So another way to write this is to say we have 1 cos 2x plus 0 sine 2x's. And so this term with the cosine and this term with the cosine has to be equal to this term with the cosine. And so if we just eliminate all the cosines, the first equation in our system is going to be negative 19a minus 8b is equal to 1. Right, so it's not really a pretty system, but it is what it is. And then we also have a positive 8a, and we have a negative 19b, which are our sine terms, and that's going to be equal to 0 sines of 2x. So we get 8a minus 19b is equal to 0. All right. And at this point, now we can solve the system using whichever method we want. It looks like that substitution might be actually easier in this case because we can just rewrite the second equation very easily. We can say that a is equal to 19/8 b, just by adding 19b to both sides and then dividing by 8. And then we could just substitute that back in right here. And so equation 1 is going to become negative 19 times 19/8 b minus 8b is equal to 1. And then I'm just going to add these in my calculator. We're going to get a not so nice number. So I get negative 425/8 b, or sorry, negative 425/8 b is equal to 1, which implies that b is equal to negative 8 over 425. And the good news is we can just immediately back substitute that to solve for a. So a is equal to 19/8 times negative 8 over 425. All right. And 8s are going to cancel, so we really just have 19 over negative 425. And that's just negative 19 over 425. All right. And so now we know what a and b are, and we can just substitute those back in. So our y of x, or let's just get y of p first. All right. So the particular solution, y of p, is going to be equal to negative 19 over 425 times the cosine of 2x, and then minus b, which is negative 8 over 425 times the sine of 2x. And finally, we're going to couple that with the complementary solution. So y at x is going to be equal to yc plus yp, which is going to be equal to what we just have above. So the negative, well, yc we already said was going to be c1e to the minus 1/2 x. So remember all the way back up top. And we got c2e to the 3/2 x, because remember m1 and m2 were respectively negative 1/2 and 3/2, plus that negative 425 cos 2x minus 8 over 425 sine of 2x. Right? And that should be our solution. Right. If we really wanted to, we could find a couple derivatives and then throw that back into the original differential. We'll just trust our mathematics this time and make sure we're okay with this. Okay, so now that we're done with this example, the next examples are going to take a look at what happens if we have any sort of repetition between the complementary and particular solutions.